Okay, today we're going to talk about constant rate of change. So we have two definitions. You have your rate of change, which is similar to your unit rate. Okay? Your constant rate of change is when you have multiple unit rates that all equal the same thing, it's constant. And so that's where those come into play. So take a moment to write down these definitions, please. Okay, I want you to follow along with this. A computer programmer charges customers per line of code. Fill in the blanks with the amount of change between consecutive numbers. So what's the difference between 100 and 50? So from 50 to 100, that's an increase of 50. So I'm going to put plus 50. From 100 to 150, that's plus 50. And from 150 to 200 is plus 50. What about from 1,000 to 2,000? That's plus 1,000. 2,000 to 3,000 is plus 1,000. And 3,000 to 4,000 is plus 1,000. Okay, so that's our change that's happening between these numbers. So the second part says, label the diagram below with the terms change in lines, change in dollars, and constant rate of change. So let's look at this. We have $1,000 on top. So is that change in lines, change in dollars, or constant rate of change? It's going to be change in dollars. How do we know that? Well, we know that because there's your dollar symbol up on the top. Okay, our bottom one says 50 lines, so that's going to be change in lines. Okay, when we take this and we simplify it, $1,000 divided by 50 lines, it simplifies to $20 per line. So that's our unit rate. So simplifying from here to here is nothing new. That's something that we've done already. But once we get that unit rate, that's what we call our constant rate of change. Okay, so our constant rate of change is $20 per line of programming code. So when we have our change in money over our change in lines, so this is going to be 1,000 over 50, if these are all simplified to the same thing, 1,000 over 50, 1,000 over 50, in these cases, these numbers are all the same. They're not always going to be that way, but in this lesson they will. So since these all simplify to the same thing, our rate of change is constant. So it's a constant rate of change. So we're going to use tables to find the constant rate of change. So go ahead and pause this and copy this down. It says the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. Okay, so the first thing that we're going to do says cars washed, so it's the number of cars and the money that they got. So what's the change from 5 to 10? It's an increase in 5. From 10 to 15 is an increase in 5. And from 15 to 20 is an increase in 5. Our money from 40 to 80 is an increase of 40. 80 to 120 is an increase of 40. And from 120 to 60 is an increase in 40. I want you to get used to writing the plus in front of it. If it's an increase, you write plus. If it's a decrease, you write minus. Right now, we're just dealing with positive numbers. But as we get further out in the book, we're going to deal with negative numbers as well. And so if you keep your plus and your minus straight as you're writing these, whether it's an increase or a decrease, that's going to help out greatly when we get to that point. Okay, so we're going to find our constant rate of change in dollars per car. So I'm going to put dollars over the cars. So what's my change in dollars? So I look at this here, that's 40. So I have $40 over how many cars? My rate of change for cars is 5, so 5 cars. Now we need to simplify this. What's 40 divided by 5? So my constant rate of change is $8 per car. So again, once we create our fraction, this is just review. It's nothing new. Okay. So for GOTA A and B, I want you to copy these down and solve them on your own. So go ahead and pause this for a moment so you can do that. Okay, the table shows the number of miles a plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. Okay, so let's find our difference between our times. So from 30 to 60, that's plus 30. 60 to 90 is plus 30. 90 to 120 is plus 30. Okay. Our distance from 290 to 580 was $290. So if you can't just see that it's 290, then what you need to do is subtract. 580 minus 290 is going to give us 290. Okay. To go from 580 to 870, you're increasing by 290. Again, 870 minus 580 is 290. And same thing for our last set of data. So we want to find our constant rate of change in miles per minute. So I have to put miles on top and minutes on the bottom. So what is my change in miles? Okay. I have to look at my measurements here. So miles is on the bottom. So I've got to use this number. So that's going to be 290 miles over minutes is on the top. So that's 30 minutes. Now I need to simplify this. 290 divided by 30. They both end with zeros, so I can cancel out those zeros. So then I have 29 divided by 3. How many times does 3 go into 29? It goes in 9 times. That's 27. 9 minus 7 is 2. I'm going to add a decimal and a 0. How many times does 3 go into 20? That's 6. So that's 18. So 20 minus 18 is 2. If you notice, it's going to be repeated. So I'm going to round this to the nearest tenth. So it'll be 9.7 miles per minute is my answer for A. We're going to use the same process for B. The table shows the number of students that buses can transport. Use the table to find the constant rate of change in students per school bus. Let's find our change in buses. So from 2 to 3, that's plus 1. 3 to 4 is plus 1. 4 to 5 is plus 1. The number of students from 144 to 216. Okay? So you'll need to subtract 216 minus 144. That gives me 72. From 216 to 288, that's 72. And don't forget your plus sign. And from 288 to 360, that's plus 72. So we're finding the change in students per school bus. So I want the number of students over the number of buses. So this is going to simplify too. So here's students on the bottom here. So I want that on the top. So it'll be 72 students over buses, 1 bus. So you could leave it like this since it's over 1, or you could write it as 72 students per bus. Either one of those would be correct. Okay, so make sure that you have that written down. Check your answers. If you got them correct, good job. If you got them right, go ahead and fix them, please. Okay, now we're going to use graphs to find our constant rate of change. So take a moment and copy this down, please. It says the graph represents the distance traveled while driving on a highway. Find the constant rate of change. So to find the rate of change, we need to pick any 2 points on this number line. So I'm going to go ahead and pick, I'll go with this one and that one. So we need to find our change in miles over our change in hours. So miles is your y. I'm going to find my change in y. So that's 180 minus 60 over your change in hours, which is your x. So 3 minus 1. Excuse me. So 180 minus 60 is 120. 3 minus 1 is 2. What is 120 divided by 2? That is 60. 60 what? What's my unit of measure? 60 miles per hour. Okay, so there's my constant rate of change, or my unit rate. If we have a straight line that goes through the origin, my constant rate of change can be found right here, where x is equal to 1. You'll just need to rewrite this. I don't want the ordered pair, I need it written down like a unit rate. So that's kind of a little trick. If it's a straight line that goes through the origin, so with proportional, where x is equal to 1 is going to be your constant rate of change. Now example 3 says, explain what the points 0, 0, and 160 represent. So yes, 0, 0 is the origin, but what does it represent in relevance to this graph? So it represents 0 miles in 0 hours. So then 160 represents, so we have miles as our y and hours as our x. So you could either write this as 60 miles in 1 hour, or you could write it as 1 hour for 60 miles. Okay. Either way would be correct. It's just a personal preference. The biggest thing is you need to make sure that you get the correct unit of measure with the correct number. And you get that by looking at your axis and what your unit of measure goes with it. So remember, we have x, comma, y. So my 1 goes with the x, so that's hours, so 1 hour. And my y goes with the 60. So the y goes with the miles. That's the biggest thing, but you can use either format to write that. Okay, go ahead and copy these down and solve these. Okay. It's the exact same thing that we just did. We just have different numbers now that we're dealing with. Okay, so use the graph to find the constant rate of change in miles per hour while driving in the city. So there's two ways we can do this. We can pick 2 points. So let's pick this point and this point, any 2 you want. You find your change in y, your change in miles, because it's miles per hour. So you want miles over hours. So we have to find our change in miles. So that'll be 90 minus 60. Over your change in hours, 3 minus 2. 90 minus 60 is 30. 3 minus 2 is 1. So that's 30 miles per hour. Also, since this is a straight line that goes through the origin, it's proportional, I can look right here. 1 hour for 30 minutes. So 30 miles, 1 hour for 30 miles. So 30 miles per hour. On the lines below, explain what the points 0, 0, and 130 represent. So 0, 0 represents, again, not the origin, it's our distance and our time. So 0 miles in 0 hours. So then 130 represents, remember, get your numbers with the correct axis. So if I were to put miles first, then which one goes with miles? X and Y. So my y is miles, so it'll be 30 miles in how many hours? X goes with hours, and my X is 1. So in 1 hour. Okay, again, it's just important to make sure that you have a unit of measure with the correct number. You could also write this as 1 hour or 30 miles. Either way works. Okay, here's our last example, so copy this down. The table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? Explain. So we have Pedals Rentals and Super Cycles. So pause this and take a moment to write it down, please. Okay. So how much does it cost for 1 hour to rent a bicycle at Pedals Rentals? So it's $24 for 2 hours. So if you divide those both by 2, that tells us it'll be $12 for 1 hour. So it costs $12 an hour to rent a bike from Pedals Rentals. Now let's look at Super Cycles. How much is it for 1 hour here? So we have the number of hours on the bottom. So we have 0.5, 1, 1.5, 2, 2.5, 3. These numbers are really close together, so be very careful how you read them. You don't want to accidentally go to the wrong one. So we have our number 1 right here. So that's 1 hour. Well, how much does it cost for 1 hour? So I'm going to follow this up until I hit my line. And then I'm going to go over. So how much does it cost for an hour? It costs $8 an hour. So which store charges more per bicycle? So which number is bigger, 12 or 8? 12 is. So the one that charges more is going to be Pedals Rentals. And as long as you show me your unit rate for both of these, so we have $8 an hour here and $12 an hour here, as long as you show me that, you don't have to explain it, because that is explaining it. But if you choose not to show any work, then you're going to need to write a sentence explaining why this is more expensive. So it's easier just to show your work for this. Okay, so that's it for this lesson. If you have any questions, just let me know.